Hi, welcome back. Today we're going to talk about linearization. Okay, so let's quickly review the proper way to calculate slope. If I have a typical y-x graph, the line is typically referred to as k, and that's the slope. Now this slope comes from the form y equals mx plus b. But our b-intercept is at 0, and so that term goes away. And so in physics we typically use the letter k to designate slope, and so our form is y equals kx. And this is a pretty standard equation for a linear slope. Well, what do you do if the slope is not linear? These are called the raw equations. And what we're going to do is we're going to show you how to turn these into a linearized line so that you can calculate the slope and plug it into a real-world equation. Okay, I just completed a lab and I'm looking at a graph that looks like this. I changed the amount of time that was allowed on a test, and then I measured the amount of points that they missed. So as I gave more time, you notice that the number of points that people missed on the exam went down. And it was kind of this almost exponentially negative type curve. We call this an inverse relationship. And I understand that an inverse relationship takes the form of y equals k over x. At this point in the lab, you're probably wondering, well, how do I solve for k? Unfortunately, I have an infinite number of slopes. Any point along this graph will have a line tangent, and so I have relatively steep slopes and medium slopes and shallow slopes, all in the negative value here. So what do? I'm going to create a second column or an additional row to the existing table that I already have. This was the existing data that I had collected, and I graphed it to get what you call the raw graph. At this point, I recognize that this is an inverse relationship and it takes the form of y equals k over x. What I'm going to do is I'm going to pull that out, and I understand that this is going to be y equals k times 1 over x. Well, I need to graph that 1 over x. So I'm going to add a column here, and I'm going to do the math. So 1 divided by 5. I'm going to go ahead and graph this new set of data. So my raw data gave me the idea that this was going to be an inverse relationship. When I see this curve, it's very characteristic of a y equals k over x equation. So I could write a real-world equation of points is equal to some constant over time. Now that's all well and good, but I couldn't really explain this k because there was an infinite number of k's. What I did was I went ahead and I added a column to my existing table where I did 1 over t, and then I graphed that on a new graph with the original points, or the original y value. And when I do that, I get a nice linear line, and it's very easy to solve for k. I'd solve this in the traditional method. I would find 2 cross points, find my rise over run, and then solve for k. Now, this linear line takes the form of y equals kx, but you got to remember that I've got 1 over time as my x value, and so when I put this into a real-world equation, my points are equal to k over time, which is the exact same formula that I had before, only now I can solve for k. So this is the method that we're going to use to adjust any raw graph that comes out as an inverse or a quadratic or a root. All right, thank you.